In this case study, the problem was that new operating conditions required a metallurgy upgrade in a fractionation column. The fractionation column, which had been manufactured 10 years ago for use at a refinery in Egypt, had remained out of service due to a change in the original operating process. Fractionation columns are crucial components in a refinery, typically operating at approximately 370 degrees Celsius, and they are responsible for creating usable fractions from heavy gas oils. However, in this case, the environment was much more aggressive than the column had been designed for. The higher temperatures would have impacted the internal surface of the column unless it was protected with a suitable corrosion-resistant alloy. The solution to this issue came in the form of integrated global services high-velocity thermal spray metal alloy cladding. IGS proposed HVTS as the method to protect the internal surface of the fractionation column and bring the asset back into service. A detailed technical proposal was submitted to the operator, which outlined the process, timelines, costs, and relevant case studies highlighting the long-term benefits of using HVTS. A total of 630 square meter of HVTS was applied to the fractionation column to prevent corrosion. In addition to the shell, smaller areas such as internal vessel tray, support rings, brackets, and other internal structures were also sprayed for added protection. The HVTS technology is widely accepted in the oil and gas sector as an effective solution to address corrosion on the internal surfaces of critical process equipment. There were numerous benefits from choosing IGS HVTS over the alternative of manufacturing a new fractionator column. For one, HVTS offered significant time savings. While the manufacturing and installation of a new column would have taken over 12 months, IGS completed the HVTS application in just 38 days, allowing for increased productivity and uptime of the asset. In addition, the cost savings were substantial. The value of the IGS project was around 50% less than the cost of fabricating a new column with corrosion-resistant alloy cladding. The HVTS solution also provided advantages over weld metal overlay. The HVTS application is much faster and offers an upfront cost reduction with long-term ROI due to material and labor savings. Savings as high as 50% are often achieved. Moreover, HVTS doesn't create a heat-affected zone, which means there's no need for post-weld heat treatment, further saving time and reducing stress on the equipment. When compared to organic coatings, HVTS had a key advantage. Unlike organic coatings, HVTS doesn't require curing time or bake out and is insensitive to atmospheric temperature and humidity. This allowed the application to reduce critical path turnaround time by up to 10 days, bringing the unit back into operation sooner. HVTS also doesn't have the low service temperature limitations that organic coatings do, and it is resistant to impact damage, which is a common issue during turnarounds. Mohammed Al-Awani, General Manager for Saudi Arabia and Egypt at IGS, shared his thoughts on the project, stating, "This has been another successful project for IGS. The client is very pleased with our professionalism and the results we've achieved. The column is now in service after 10 years, and we have significantly extended the lifetime of the refinery's mission-critical equipment in a cost and time-efficient manner. We've saved our client 12 months of production by bringing the existing column into service rather than having a new one manufactured." IGS has also been called to inspect other crude distillation columns during the plant's next shutdown. That's it for today's case study. Join us next time. Don't forget to subscribe to this podcast for more project stories like this.